Keshav, Divya, Kanishka, good morning. Last class we were discussing about good morning everyone. Last class we were discussing about Ekta. Good morning, beta. Tomorrow evening I will keep class or not, you have to inform me now only, okay? Yes, today I am going to do Rutherford experiment, beta. That was a very important, that means that time the problem was, I'm just started discussing about the problem when Rutherford exactly experiment has been done about structure of atom. Many things are there, you have to understand one by one. Now first thing is, so now most important thing about structure of atom. Just 1 minute, beta. This. Some believe Rutherford too. Tomorrow you can keep auntie. Okay, evening I will keep the class. Morning I will not disturb you. Now look here. Rutherford experiment was there. In the Rutherford experiment now, we learned a very important thing. That is about structure of atom. Now we went one step near to the structure of atom. Because J.J. Thompson experiment, it was not at all near to the concept of structure of atom. It was just a concept which was made to understand that or made to tell people that atoms are electrically neutral. See, based on the watermelon experiment or this Christmas pie experiment, we can conclude only one thing. Since I have to tell that atoms are electrically neutral, then keep one thing in the material as positive charge and another thing in the material as negative charge and tell them that they are exactly neutral. So this was the only work it has been done there. So there was nothing like, it was nowhere close to the real structure of atom. Fine. But one accidental experiment has been done, or many people don't know about it, but yes, most of the experiments which were done accidentally was exactly a very big hit. Okay, now I'm just going to talk about it. First, you send one information in the group that evening I didn't keep class, but now only I'm keeping class, and that too I'm full day you will be free. Tell them to attend the class. Okay, now look here, Rutherford alpha particle scattering experiment. Now in this experiment, Rutherford has done some work, and that work is exactly called as the pioneer for understanding. See, though he was not successful in drawing the structure of the atom, I am not saying that Rutherford was 100% successful in depicting the structure of matter, structure of atom, but he was very near. Only one structure mistake exactly made him go beyond that line of perfection. Okay, only one structure mistake. Good morning, Vishal. Good morning, Vishal. Vishal, your question, what you have given, yesterday my headache was there. So only after seeing your question, I didn't respond it. But today, 100% I am going to send the solution. After returning from school, I will solve and I will send the solution. And I will send the solution in group only. Okay, so that everyone can see. Now look here. Okay, so now look here. What was exactly alpha particle scattering experiment? Discovery of nucleus. So what was J.J. Thompson experiment? It was exactly only one thing was there, that electron, yes, that is it's not about emission of energy, it's about spiral structure, beta. Exactly, fault was not in understanding that emission of energy is there. 100% a very active particle, subatomic particle, do have energy in it. We have already seen that electrons are having charge. It is having charge by mass. So the thing here is, since a very active metal, yeah, I'm going to explain from first. Actually, I have not started till now. I'm just starting, Vishal. I'm not. I've just started. Now only I'm starting. Okay. So I'm just starting talking about the Rutherford experiment. In this experiment, actually, what he has done. See, alpha particle, doubly charged helium atoms are exactly called as alpha particle. Now, he has exactly bombarded this alpha particle into a very thin gold foil, and after that he understood the behavior of the rays which is exactly emitted, the alpha particle rays, how the alpha particle rays behaved, what they did they crossed, did they did they got absorbed by the thin gold foil, or did they got reflected by the thin gold foil. See, see, if any structure is there, you have to understand one thing. Just understand one thing, that positive or negative always attract each other. Okay, so if I am sending positive charges to you and you are negative charge, then what you will do? Just tell me answer. If I am positive charge and I'm just sending positive charge to you, if I am sending positive charge to you and you are negative charge, what you will do? You will counterbalance positive negative charge. Means you have negative charge, I am having positive charge, we released positive and negative. Then what positive and negative will do? Positive and negative will make itself electrically neutral. One positive, one negative, counterbalanced. One positive, one negative, counterbalanced. One positive, one negative, counterbalanced. So always the positive will counterbalance the negative. So this will exactly be possible. So but one very important problem here is कि Rutherford, when he sent the positive particles, then he saw that this positive, rather than getting absorbed and nullifying the effect, it is exactly throwing back the light again. So these rays are exactly getting thrown back, and this is exactly the finding. And this finding, most of the rays were exactly passing and only one were reflected back. So why this is possible? There were many confusion. Then his conclusion or final observation has cleared many of the doubt. So first, one by one I am going to start. Now look here. In order to prove J.J. Thompson atomic model, Rutherford conducted alpha particle scattering experiment. Yes. So exactly J.J. Thompson, that is what the concept is now. You want to prove that Khushbu aunty has told something and that statement is true. So can I explain that statement in my own way? Can I explain that statement in my own way? For experimenting, for explaining that concept in a different way, he conducted an experiment. Okay, so I'm just telling you, by explaining his concept, J.J. Thompson's experiment, in a different way, with the help of the gold foil, he conducted an experiment and accidentally everything happened. Fine. So now let's see what happened there. So he reasoned, positively charged mass present within the atom is thinly spread, then any positively charged particle moving with sufficient kinetic energy would easily penetrate through it. Rutherford selected. So this was exactly the concept of Rutherford. Please kindly, I am underlining the most important point there, beta. I am underlining the most important point. Please do have a check in this point. So exactly what was his conclusion behind saying this point? He said one important thing there, that he has given a reason. He reasoned if positively charged mass present within the atom, positively charged mass present within the atom. See, who said that positively charged mass is present within the atom? Who said that positively charged mass is present within the atom? Then you will say, ma'am, positively charged mass present within the atom was said by J.J. Thompson. Who said this? Positively charged mass is present within the atom. Who said this point? Who said this point? Positively charged mass present within the atom was given by whose concept? Whose concept was this? That positively charged mass is present within the atom? It was J.J. Thompson or Rutherford? It was J.J. Thompson or Rutherford? Yes, J.J. Thompson. Absolutely correct, beta. It was J.J. Thompson who said this point. Sharmila, good morning, beta. So it was J.J. Thompson who said this point, that if positively charged mass present within the atom is thinly spread, then any positively charged particle moving with sufficient kinetic energy would easily penetrate it. That means if positive charge is less in the, if positive charge present in the atom is very thinly spread. Thinly spread means if less amount of positive charge is there. If less amount of positive charge is there, if less amount of positive charge is there, then another positive charge will pass through the atom. Okay, so just understand the concept of Rutherford. Rutherford said that if atom is having very less number of or scattered positive charges, then any other positive charge, when they will try to come inside, then they will penetrate the atom and go out without deflection. This was the concept. This was the concept, that the positive charges inside are thinly spread, exactly scattered. Then in between the region of positive charge, if any positive charge is crossing, then rather than repelling each other, it will cross the atom and go out. Rather than repelling the atom, it will cross the atom and go out. This was the concept, beta. Rather than repelling the atom, it will cross the atom and go out. Okay. I hope you might have understood. So he exactly wanted to prove this point, that if atom positive charges are thinly spread or scattered, then in between the region, the gap, the positive charge, another positive charge, if it will come, it will cross it. It will cross it. So Rutherford selected gold foil for his experiment. Gold is the most malleable metal. Hence, it can be converted into thin sheet. He took a gold foil which has around 1000 gold atoms. So, what type of gold foil he has taken? He has taken that gold foil in which almost very thin gold foil he has taken. Okay. Now, why he has selected gold foil? What is the reason of selection of gold foil? The reason of selection of gold foil was very easy. That is, he was wanting a limited amount of atoms. He was wanting a limited amount of atoms on the foil. He was wanting limited amount of atoms in the foil, and he expected how much for atoms to be present, how much gold atoms were present. Come on, quickly tell me how much or how many gold atoms were present in that thin gold foil. What was the expected number of atoms in the thin gold foil? Expected number of atoms in the thin gold foil. Come on, quickly tell me. Jiva, good morning, beta. Very good, Vishal. So expected number of atoms in the thin gold foil were 10 to the power 3, that is 1000 atoms. Okay, so the thin gold foil was then 1000 atoms thick. Okay, after that, correct Sharmila, Ekta, super beta. So now he placed the gold foil in middle of circular zinc sulfide screen. Now we are going to see where the gold foil was kept. See, this is the thin gold foil and where the gold foil was kept. You see, this is the exact copy of it. So you see, this is the thin gold foil. Now in this thin gold foil, what is happening? This chamber is the source of alpha particle. This chamber is what, beta? This chamber is the source of alpha particle. Now from this chamber, alpha particles are bombarded. Bombarded means it is exactly striked, it is exactly sent to what you call to strike the metal surface. Which metal surface? Gold metal surface. And which metal surface? Gold metal surface, whose thickness of the metal is 1000 atoms. Whose thickness of the metal is 1000 atom. Now after bombarding, the beam of alpha particles are exactly striking it. So when beam of alpha particles striked it, so to surprise, we saw that the rays are exactly, most of the rays are exactly coming out undeflected. But some of them exactly, so expected was all will come out undeflected. Expected was all will come out undeflected. But some of them, you see, they come out, they made some angles, and very few has exactly traced back its path. Traced back its path means going in same, going to with, means you are going from home to your school. So your area means your way of going is fixed now, and then from school to home fixed, returned. So you on returning from school, you will just return back to the same path. Same way, this particle, it went like this and it returned like this. So only few, very few just did that one, and most of them exactly crossed the gold foil without deflection. Some made certain angles. Yes, but I am going to explain that these alpha particles were doubly charged helium atoms. What does doubly charged helium atoms means? I am going to explain this one. Doubly charged helium atoms. They are exactly called as doubly charged helium atoms. So alpha particles are alpha particles are doubly charged helium atoms. I am repeating, doubly charged helium atoms. So what does doubly charged helium atoms means? I am going to explain. But see this is exactly the zinc sulfide screen. This screen what he has taken for the experiment was zinc sulfide screen. What screen he has taken? Zinc sulfide screen. So some of the alpha particles, so zinc sulfide screen, why taken zinc sulfide screen? So that we can be able to see the reflected, means the reflected particles. So when the reflected particles will strike it, we will be able to get the exactly strike rate, and we will be able to get where it has struck. So for that only he has taken zinc sulfide screen. You see this gold foil and you see how rays were exactly going out. Now look here, the correct picture of it. So inside the gold foil, what is exactly the case? Inside the gold foil, the case is this one. Most of the alpha particle went and exactly crossed without deflection. In between the atomic structure, most of them went and crossed. But some of them which were exactly touching, going very near to the center, they came out where they came out, they reversed their direction and came out. So very few were there. So now we are going to start the concept. See, now first I am going to explain about doubly charged helium atoms. So doubly charged helium atoms means, you know that helium is noble gas. Noble gas means what? Helium noble gas means that they are very inert. In group 18, so our periodic table is divided with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So our periodic table is divided in 18 groups. How many groups? 18 groups are there. So our periodic table is divided with 18 groups. So exactly in 18 group, the 18th group is exactly called as noble gas family. So they are exactly what? They are exactly family of noble gases. What they are? They are exactly family of noble gases. Group 18 is the family of noble gases. What is group 18? Group 18 is the family of noble gases. Fine. So now in group 18, whatever gases are there, they are stable, they are inert. They do not take part in reaction. Because see, look here, when you will take part in reaction, see, if you need something, then only you go out and do work. If you want to give something, then only you will be exactly, understand one thing, if I am having something extra, I will give it to you. So when I am having something extra and I am giving it to you, that means what? Ki my whatever extra content is there, after giving, I am stabilizing. Okay, that means I am reactive. I am reactive because I am having extra and I am giving it to you. After giving it to you, I became stable. Now another type of atoms are there, those who need. So they take electron. So some atoms are there, they take electrons. So beta, when they take electron, they become stable. So one type of atom is there, they give electron and become stable. One type of atom is there, they take electron and become stable. But this is the one family where they neither give or take. Without giving or taking, they are stable. Without giving or taking, they are stable. So what is the elements present? Helium, neon, argon, krypton, xenon, radon. So these are the noble gas family members. Now this helium is exactly having outermost 2 electrons. This helium is having outermost 2 electrons. Okay, so this helium atom is a stable atom and it is having outermost 2 electrons. Now what we have done is, we have plucked out the 2 electrons. So without plucking out, helium is very stable. It will not at all do anything. Helium is very stable. But here what we have done, we knocked out the electron. So when we knocked out the electron, so now it is doubly charged helium atom. So now since electron is out, without electron, it is just a nucleus. It is just a nucleus. Now this is exactly called as alpha particle. Now this nucleus is exactly only positive charge is there. No electron is there. Because electron from the outermost orbit is out. So that's why these are called as alpha particles. So alpha particles are positive charge particles. Alpha particles are what? Positive charge particle. Why it is called as alpha particle? Why it is called as alpha particle? Because here from the atom we have taken out negative charge. That means electrons is out. So negative is out. So only nucleus left. And nucleus is positively charged. And they are exactly having penetrating power. So these alpha particles, after getting charged, so these helium atoms, after becoming doubly charged helium atoms, they are very active and they are exactly called as alpha particle. I hope now you have understood the entire story of which type of alpha particle is taken. So beta, alpha particles are positively charged helium atoms. Means If somebody will be asking what does the positively charged helium atom means, you say that helium is a noble gas, stable gas. From this noble gas, stable gas, we have exactly plugged out 2 electrons. So when we have taken out 2 electrons, helium become very unstable. Helium become very unstable because now helium is only having positive charge left. So since helium is only having positive charge left with it, they are called as doubly charged helium atoms. They are exactly called as doubly charged helium atoms. I hope you might have understood this concept. Understood this concept? Come on, quickly tell me. Understood or not? Very good, Vishal. Sharmila understood. That was a very, very important point, beta. That was a very, very important point to remember. Ekta understood. Super. So now we are going to go to the Rutherford expected alpha particles. So now what was Rutherford's expectation? So what was Rutherford expectation? Understood, Jiva? Super, beta. So exactly Rutherford expectation was, hey, the particles, see, look here. So atoms are exactly arranged like this. So now his expectation was that all will cross. His expectation were all the rays will cross. Okay, all the rays will cross. But what happened beyond his expectation? Something else has been done. The one which was very the ray which went very near to the nucleus bounced back by making certain angles. Which went very near to the nucleus, they bounced back. And the rays which were exactly far from the nucleus, they came out without deflection. They came out without deflection. What they did? They came out without deflection. They came out without deflection. Can I tell you one very important news? For joining for 10th class na, coming batch, students started calling me. So now current batch, how many are there? I will take them in 10th or not, I don't know right now. I'm telling you clearly. If they have to study with me in coming 10th batch, they have to be very regular. And I'm seeing them, some of them are not at all attentive. So I will take new, I will release old. I can do that. Now, did you understood the concept? Was the experiment according to the expectation of Rutherford? Was the experiment, I'm telling you the truth. Right now you have not given examination also, but I started getting call for the coming batch, 10th batch. Who are interested to join, they started calling me now only. So let's see in future who will be with me. Because it will not be online every time. I know, Kanishka, you are regular. You will be with me. No matter what will happen, I will be with you. The children who are very regular, I will 100% be with them. Understood, Sharmila? So, beta, we have understood one very important concept here. The structures which are exactly very near. Means some rays, it went very near. So, beyond expectation, work has been done. He expected that, okay, some of them will be exactly going, all maximum will pass. But, yes, Arif, maths is there today. Today you will be getting a set paper, beta. Today I just set a paper for you for questions. question paper you will get today for class. Question paper means this PDF we are going to solve. PDF papers we are going to solve now. Now look here. So that means expectation was what and reality went what. So expectation was Rutherford expected that alpha particle to pass through the gold foil and produce bright scintillations at point A. So his expectation was produce bright scintillation at point A. Scintillation at point A means it will exactly produce some light there. Okay. So scintillation it will produce. Yes, beta. Scintillation it will produce. But what happened? However, to his surprise, some of the scintillations were produced in region B. But problem here is some of the scintillation is produced at B. Some of the scintillation is produced at C. Some of the scintillation is produced at D. That means other reasons scintillation is produced, which is exactly a very big shock for Rutherford also, because you expected something and you are doing experiment to prove that point. But when you started the experiment, things came out totally different from your expectation. So exactly Rutherford experiment was to give a back support to J.J. Thompson experiment. Literally, if you want to understand in simple language, that means best buddies, I am going to support you by telling your point is absolutely correct. But when I started experiment, I came to know that his concept, what he has said, many backflows are there in that. And that backflows, one of the backflow is about the structure of atom. That is, he told watermelon concept, J.J. Thompson said watermelon concept, that the seeds are positively charged, the region is negatively charged, and positive and negative electrically neutral. See, though J.J. Thompson experiment was so much important and it was so much there for perfection about structure of atom, because one concept he said about electrical neutrality, that concept was bingo. It was bang on, absolutely correct. Positive charge equal to negative charge. That was exactly correct, and it has been taken also. Come on, it has been taken also. Nucleus is having 10 protons, then electrons are present outside the nucleus are also 10 in number. So that is exactly electrical neutrality concept was correct, but structure was wrong. Okay, the neutrality concept was correct, but what was wrong? Structure was wrong. To rectify the structure, it was exactly given the concept that, okay, expectation is that when they will strike the gold foil, the most of the scintillation will be produced here. But where is the scintillation produced? The scintillation produced is in some other regions also. So the scintillation produced in other regions prove that there is something in that atom where exactly it is striking out and it is defending out the structure strongly and allowing the rays to come out by making certain angle and allowing the rays to come out by making certain angles. That was the jackpot point of the experiment. Okay, so scintillation produced. So now we have to understand that these observations can be explained only if you assume that positive charge in atom is concentrated in a very small place where the atom is. So correct only now. In the experiment only, whatever we have seen, one very important point we have seen that atom structure, if positive charges are nicely spread out, then positive will come, then positive penetration, rather than having penetration, they will have repulsion. They will have repulsion. So if any positive will come, just understand, think about this concept. There's watermelon is there and positive is there. Then whenever positive will come, strike this one, it will have repulsion. It will have repulsion. It will have repulsion. It will all have what? It will have repulsion. But rather than that, what happened? Though the positive charge were not evenly spread or not spread out, it was concentrated into a very small region. It was concentrated into a very small region. The positive charges, the doubly charged helium atom, when it went near to the atom or it passed the atomic structure also, it went out without deflecting. It went out without deflecting. Only a very few of them which went very near to the structure bounced back. Which went near to the structure bounced back. So exactly this proves that the structure of the atom, in the structure of the atom, the nucleus part or the positive region, I am not talking about nucleus positive right now, after his discovery only this conclusion has been drawn. So the what you call the positive charges only striked to a small region, and had deflection. Only strike to a small region and had deflection. Okay, so this was a very important point to remember. Okay, I hope conclusion drawn you have understood. So most of the alpha particle pass through the gold foil straight without undergoing any change in the direction. We have seen most of them are going out straight without showing any deflection. Second, a small fraction of alpha particle deflected through small angles, and a very few in number with large, very few alpha particle deflected by making large angles. Can you see? Very few, but most of them exactly slight deviation in angle is there. So slight deviation is in angle is there. If you want to see, you see there are very slight who went very near to the structure, very near to the atom center. They only got slightly deviated. They only get slightly deviated. And only very few, just like see this, they came out by making certain angle. They came out by making certain angle. So this perception was exactly very important to discuss. So 1 out of 12,000 particles rebounded. Rebound means return back. Okay, so 1 out of absolutely correct, Vishal. Since protons are present and protons are positive charged, so that time since protons are present and protons are positively charged, what is present? Protons are present and protons are positively charged. Because of that only beta positive repulsion has happened. And since repulsion is there, positive when will go near to positive, it will do what? It will repel. Positive will go near to positive, it will do what? It will not attract. Come on, is it cannot be a case of attraction. When positive will go near positive, it will exactly repel. It will exactly repel, and this has been done. It is going to repel, and this has exactly been done. This has exactly been done. So for the above experiment, Rutherford draw the few following conclusion. So what was the conclusions of Rutherford experiment? Now the conclusion was most of the alpha particle pass through the gold foil straight without undergoing any change in the direction. This shows that there must be enough space within the atom. We proved J.J. Thompson wrong. We proved J.J. Thompson wrong because J.J. Thompson said that the atom nicely positive is present and negative is present in between it. But wrong. Why? Because most of them crossed. So that means positive is not present. There is much vacant space. There is much vacant space. There is much vacant space in the atom. And this is what the first point is. That is, there must be enough space within the atom. And since only very few out of 12,000 rays, only one rebound. 12,000 out of 12,000 particles, only one rebound. So ratio is 12 is to 1. 12,000 is to 1. Ratio is 12,000 is to 1 rebounded. 12,000 is to 1. Think about it. And only one which went very near and strike the nucleus, only it rebounded. Only it rebounded. So that means the ratio is exactly very less. The ratio is exactly very high. Sorry, ratio is very high, and the chances of striking is very less. Okay. So now we are going to go for the next one. Since alpha particles are positively charged particle, theirs could be deflected only by positive charge. Yes, from the beginning part of today's class, I am only talking about positive, positive repel, positive, positive repel. I told you helium is positively charged particle, and how helium is positively charged, that too also I told. I told that from helium take out 2 electrons. Now only nucleus is left, and nucleus is positively charged. Because of that it will be positively charged. So now so in the gold foil experiment, some alpha particles were deflected through small angles and few through large angles. So that must be passed close to the positive body. The alpha particle which deflected through large angle passed very close to positively body. Okay, now you will have one confusion. Auntie, they were talking about positive charge nucleus. They were talking about atoms having positive charge distributed in atom, auntie. Then how helium positive charge has been taken, auntie? Because they don't know that time that nucleus is positive and electrons were there. Only you have to understand one thing that time, कि when he took helium, because this concept will be there, you will get confused. Right now what concept is there I discussed to you, but if somebody will be asking you, because somebody can cross question you na, somebody can say you that time atomic structure was not there, and Khushbu auntie said that कि nucleus is positive charge and electrons were plugged out. Electrons were plugged out. So that time you have to understand, whatever positively charged helium atom has been taken, it has been taken by the concept that helium is having positive and negative both. Okay, and what they did is they charged the helium atom. See, they exactly took helium atom and they charged the helium atom. So when they charged the helium atom, it was exactly like taking out the negative charge by giving extra positive charge. So when extra positive charge is given, then negative will counterbalance with positive, and remaining positive charge will be left, and remaining positive charge will be left. So that was the concept about helium atom. So helium atom, that was not like that. But nucleus, now we know the precise information that electrons plucking out, then nucleus is left. Electron plucking out and nucleus is left. Nitish, starting beta. I am going to start class 10th now only. Today PDF we are going to see. Okay, class 9th, all the best for your tomorrow's examination. Okay, I have to start class 10th beta. So remaining part we will do in next class. Tomorrow evening I will keep class beta. Tomorrow evening I will keep class.